Hello, it's Mr. Brown. We're back with our OSI model podcast. We're in the third part. So we're looking at, we just left off at layer 4, so we're on layer 3 now. We're looking at network layer. If we look up the definition for network layer, this is what we see. Provides a functional procedural means of transferring variable length data sequences from source to destination via one or more networks while maintaining the quality of service requested by the transport layer. That usually elicits a, yeah, that's nice. Well, if I boil it down, it really amounts to it's responsible for sending data packets to the correct network. Kind of like the post office in dealing with your mail. As I send a letter through the mail, the post office is the one that's responsible for picking that up, reading the zip code, reading the state, reading the street address, sorting it out, getting it on the right truck, getting it to the right postal carrier, getting it to the right bag, and then the postal carrier getting it to the right mailbox. Once it gets to our mailbox, they've done their job. They have routed the envelope, the letter, through their system to the right mailbox. They've routed the data packet through the network to the right network, the mailbox at the house. Okay, so that's really what's going on at the network layer. So this is the layer really where routing occurs. That's where the routers really occur. That's where routing occurs. So I always kind of, with layer 3, kept telling myself, router is routing. That's what's going on at this layer. So that was a way for me to kind of tie a tangible item to this layer. So routers are operating at this layer, reading the data frames, deciding where they go, and getting them to the right network. And they do that with the assistance of an IP addressing scheme. We have everything organized by IP addresses. The routers pick up the packets, read the IP addresses, and decide where they go. It's a logical addressing scheme. And the IP addresses are designed that there is, as the book says, a hierarchy where they're organized in such a way that the routers can understand, oh, this network's over here or this network's over here. Kind of like looking at a road map with all the highways. It's organized in some way that I can look at the map and look at the roads and decide I want to go 83 to 81 to here to there. I can make my route and work my way through the system. So let me jump over to our packet capture we had done earlier. I actually ran a new one real quick since the last time I did a podcast. It's almost identical packet capture I'd done before. I have my filter in here where I'm showing the first 3 handshakes of my TCP 3-way handshake, and then I'm transferring data. Well, I'm going to grab my HTTP packet here, pull it up in a new window, and one of the things I see in here is if I look at this a little closer, here's my HTTP, that's my application layer protocol. TCP, that's my transport layer protocol, right? You're starting to see it now? And next to that is my IP protocol. So here's my IP header. I'm going to open that up, and these are all the fields that are in the IP packet or the IP header to address this packet to get it to its destination. So this would be kind of like looking at the envelope on a letter and reading the address label. Hey, this address is going to Doug Brown at 123 Happy Street, Mechanicsburg, PA 17055. This is identifying Doug Brown in Mechanicsburg as to Doug Brown in Lima, Ohio, for example. So all this stuff's in the IP packet header to make sure the data is getting to the right network so it can get delivered eventually to the right node. So in here I start seeing source IP address, destination IP address. And that way, as this packet is getting moved through the network, a router can pick that up and go, oh, I know where the 74206 network is. Go this way, you'll get there. Kind of like stopping and asking for directions. Hey, do you know where Interstate 83 is? Yeah, go over this way about a mile. You'll see signs for it. You can't miss it. So the router is looking at these addresses, picking up the packets, reading the addresses, and saying, yeah, I know where that is. Go this way. Keep going that way. You'll get there. Okay, so that's the function of layer 3. Routers picking up the data packets and making decisions and moving them through the network. That's your layer 3. Protocols and things that are going on here are things like IP, ICMP. Most of you know ICMP is ping, ARP, RARP, those sorts of things, traceroute. These are all things and protocols occurring at layer 3. And then our IP addressing scheme, which we'll get to in detail a little bit later. Other devices here, we have routers, we have layer 3 switches, which we'll talk about a little bit later, as well as firewalls doing some work here at layer 3. So there's a couple things you can kind of stick in your basket for layer 3 to help that sort out, as opposed to other layers of the OSI model. So routing, path decisions, that sort of thing. Layer 2, data link layer. provides a functional procedural means to transfer data between network entities, network nodes. So this one is here really to get data onto the network, and as it's moving across the network, get it off the network and try to get it to the right node. So this one is where I like to think of as NICs occur at this layer. Okay, I'm going to drop down here. These are my NICs occurring at this layer. And the NIC is really, when I think about it, connection between my computer and the media. Because this snaps into the motherboard of my computer, and over here my media snaps in my patch cable. So this is the connection kind of between my computer and the network. Well, vice versa, if I have data packets coming on the wire, it needs to come in here, and this thing needs to say, yeah, this data packet's for this computer, or no, it's not for this computer. So my NICs being layer 2, this is kind of the connection to the network. So this is responsible for media access, getting the data onto the wire. Things like Ethernet use CSMACD, which we'll talk about soon. Carrier sense multiple access with collision detect. That's a way for Ethernet to look for a gap on the network and send the data on the network. Protocols and things, this is mainly Ethernet that's occurring here. Access methods, that sort of thing. All right, let me go back to my packet capture we had done earlier. Here's the one I had up just a couple minutes ago. HTTP, TCP, so HTTP is my application layer, TCP is my transport layer, IP is my network layer. I'm going to close that one now, and I'm going to open up the next one down here, Ethernet, which is my data link layer. There it is. There's my Ethernet header, because it's coming from an Ethernet network. And in here I see the source and destination addresses, the source MAC address and the destination MAC address. So on layer 2 with my NIC, I'm also going to start encountering MAC addresses. This is your 48-bit hexadecimal number. That's why you see letters and numbers here separated by colons. So let me go back here. So addressing implemented here is my physical addressing, the MAC address that's burnt into my NIC, 48-bit hexadecimal number. This is identifying my computer on the network. So if I think about it, if I have an IP packet start to come towards my network and the router routes it into my network, once it gets into my network, my NIC will see this packet and go, hey, yeah, that's for me. And it'll pay attention to that packet. Meanwhile, other computers go, I have no idea what that is. Get out of here. That's not for me. And it'll throw it out. So this is the piece. This is the address that my NIC will pay attention to. Anything addressed for that, my NIC will pay attention to. Anything else, it's going to throw out. So this is my layer 2, my data link layer, my NIC, my MAC address, my 48-bit hexadecimal number. This is all stuff with layer 2. And there's some NICs. And then below that I also have some switches. These are some things that occur at layer 2. My router connects to my switch connects to me, my node, my computer. So this is the piece that's going to pay attention to MAC addresses, my switches and my NICs. Last layer of my OSI model is the physical layer. This is relatively easy because it's the physical link. It's the actual physical cable, copper cable or fiber cable that is connecting those together. So this one is defining electrical and physical specs for devices, concerned with the ones and zeros, sending of electrical pulses or light pulses across the network. This is my physical link. The things here I don't really have any addressing. And the devices I have are all what I like to say dumb network devices. They don't read any addressing, they don't make any path decisions, they just simply get the signal and repeat it in some manner. A media converter would get a copper signal on this port, turn around and turn it into a light signal over here for the fiber ports, and away it goes. It's not doing any decisions, it's just converting. Here's another media converter. Over here are hubs. Hubs are dumb devices. As it gets a signal on one port, it turns around and repeats it on all ports. Just repeating it out. That's all I do, man. So my physical layer is just simply your cables, your connections, your electrical pulses, your light pulses, and a couple simple devices like media converters and hubs that occur at layer 1 of the physical layer. And I also have some pictures here reminding you of all the copper connections and fiber connections. This is all stuff occurring at layer 1 of the OSI model. So there we go. There's our layers. Application. We did application the whole way down to physical. There's my layers. This little picture that I borrowed, these little icons try to give you an idea of what's going on at each layer of the OSI model. It's actually a pretty good idea. I also have this chart out on D12 for you. This kind of gives you a summary of all that stuff, kind of throw it all in one big chart for you. So there you go. There is your overview of the OSI model.